Is it recording? There we go. Okay, now it's recording. Okay, Matt, you now have the floor.
Lovely. Thank you so much. Glad to be back. I enjoyed my talk last time here, and this is an interesting topic for me. For those of you who don't know me, I am, right now, I'm a software engineering instructor in Columbus, Ohio. In a few weeks, I'm going to become a senior solutions developer too. So going to be doing consulting with software engineering and machine learning and things like that. I'm out of Columbus, Ohio. I'm a Microsoft MVP in artificial intelligence, and I do a lot of fun stuff with Python in particular. I am halfway through a master's program in data analytics. Tomorrow I'm starting a new class that's going to be covering something called Pandas and Python. So it might be a pretty boring summer for me because I think I know most of what they have to teach me right now. But that's what we're talking about today. I want to show you Jupyter Notebooks and data science notebooks and mixing together code and Markdown to do sort of data analytics work together. And we're going to be using Python and Plotly. Plotly is a data visualization library. We'll also be using Pandas, which is a way of manipulating tabular data. So this is Visual Studio Code. I don't have any slides with this presentation, but the code is entirely available. I put that in chat earlier. But we're going to just take a look at a Jupyter notebook. So this is a Jupyter notebook. It's named O1_Python Jupyter IPy notebook. This is something that runs on a kernel. Notebooks are a combination of cells. So this Jupyter notebook's up here, that's a cell. This hello world here, that's a cell. This little code thing is a cell. Cells are either going to be markdown cells, like this top one here is, or they're going to be code cells, like this one over here is. And what this lets us do is it lets us mix together documentation and code. So that way, I'm going to ask yourself to mute if you're not speaking. Just getting some breathing in the background there would be helpful, just for distraction purposes.
I'll get it. I'll get
it. Thank you. But this is just some markdown cells and code cells, and this lets us mix together our markdown and code and have like a really rich documented experience where people can type in, whatever Python code they want. So let's say they wanted to print out hello NumPy and give that a run. Control Enter will run your cell, or you can click the little play button if you are so inclined. You can add in new cells, so I can have a new variable here, say group name equals NumPy. And if I have that cell here, I can add another cell over here. I can say print hello space group name. And I see I have that variable available to me in later cells. So I have these variables that all live actually kind of in this little, I hate to call it a register, but it's kind of like a register. We have the shared global variables that we have. Here I have one named group name, that's a string, and I can now refer to this in any cell I want, which is really cool. One thing I think is really neat about Jupyter Notebooks in particular is that if I have, say x is 4, y is 8, z equals 100, and let's say I want to say result equals x times y times z. And if I wanted to print this out normally, I'd have to say, well, print, str result to convert result to a string and then print out that. But with a cell, I could actually just say my last line is a variable, and it's going to print out the result of that just automatically below it. So 3200, yeah, that looks about right. So we'll say that's correct. So this lets us mix together, markdown cells and code cells together. And that's sort of the idea of a notebook. And this is, fairly simple here, but you could imagine this with maybe some more documentation related to the projects that you're trying to do, or something you're trying to teach if you're using this in a teaching setting, or some data analysis experiment or machine learning experiment that you're trying to run. You can use that really with good effect here. So it's a single document that has all this code and markdown mixed together that someone else can replicate and tweak and customize. You can have standard things that you have in Python, such as functions. So I can define my say hey message function, and then I can call it. I could say hey message. It's hey NumPy. So kind of cool. You can have it read it from a file as well. I don't have a good example of that ready, but you can import file things from files. If you were so inclined, you could create a class and just run that cell, and then now you can actually go out and you can create a new class. So I can say p equals. So I'm going to instantiate it. P equals a point.
Hey, Matt, I'm sorry to interrupt. We had a request to increase the font size, please.
Oh, I can absolutely adhere to said requests.
Thanks.
I'm going to do that several different times. There we go. That ought to be a little excessive, but that's fine. That works well on mobile. You need me to tweak it further, just let me know. That's great to get that request now instead of later when I'm on the charts when it messes with the charts. So that's great. So here's a point. Its name is P, and I'm just going to have my last thing in my cell here be that point. And so now I've instantiated it, and I see, well, I've got, well, this is the string representation of the point by default. But if I call str this, that's going to call that str method, and we get the string representation. I could also maybe say p dot x comma p dot y, and I get a tuple there with the value. So these Jupyter notebooks, they let you run code using a kernel, and that kernel is either running on your machine or some remote machine. In this case, it's a kernel I have on my machine. It's actually the Anaconda 3 Python environment, but I could have selected another one if I had another Python environment installed and chosen to use that. Or I could use like a remote server if I had one available to me as well, which is pretty cool. But you can kind of squint at this and say, hey, if I mix together my documentation and my code, I can really kind of show people how to use my classes. I could show people the results of an experiment. I can give them this file, and they can replicate my results or tinker with the settings and do whatever they need to with their heart's content. And that's sort of what this Jupyter notebook thing is. And it's not just limited to Python, by the way. Jupyter stands for Julia, Python, and R. So you can connect it to the Julia programming language, the Python programming language, or the R programming language by default. But one of the things I'm writing about nowadays is something called polyglot notebooks, which is someone has written a .NET kernel, so you can actually run C#, F#, SQL, KQL, HTML, JavaScript, all of that stuff inside of a notebook, and it's just insane stuff. And I'm fairly in love with that at the moment. So if we have
Okay,
interest at the end today,
if I could interrupt you
please.
one more time, another one. Have you heard of RESTbook?
I have not. What is that?
So RESTbook is basically taking the Jupyter Notebook interface and so you make calls to REST APIs for it. So it's kind of like a Postman, except it's in a notebook form. Very useful. It's it's extension
Ah.
for Visual Studio Code.
Okay. I've used PowerShell in Polyglot notebooks to do very similar. So that's interesting. I'll have to take a look at
Hmm.
that though. That's interesting. But the idea is you can do these little iterative experiments where you're not creating a whole new application. You're just writing a little bit of code and running it and getting a quick iterative result and able to adapt after that. So it's really good for things where you're experimenting or things when you are just iteratively teaching something like I do in my day job. Um, so I think there's a lot of benefit to this whole idea of a notebook from a teaching and learning perspective, as well as an experimentation. And I'm finding that personally, I'm building less applications and more notebooks as I'm playing with things and saying, okay, how do I work with this API? How do I work with this thing? Um, and so finding notebooks in general has really changed how I look at programming, which is nice. But it's not necessarily something you're going to deploy either. It's its own type of application, if that makes sense. Any other questions before we move on to introducing pandas and tabular data?
Yeah, just a few. So Sherry asked if there's going to be a link to this Jupyter Notebook, and you're going to provide you said you'll provide the code, and we'll put that on and I'll put that on Memphis Python UG.github.io. It's already there.
Yep.
And then Tolu is asking, do you have any experience using Jupyter Notebook on a Mac on an M2, one of the
Ah,
new Apple M2 processors?
So a fun thing about asking me any question about running anything on anything Mac related is the answer is going to be no. Uh, I'm very much a PC guy, so I've not tried it. I don't know. I haven't heard anything that would prohibit you from doing that, but that's certainly not anything that I've been experimenting with myself.
I'm still on an Intel Mac, but Jupyter Notebook now, if you're talking about GPU acceleration, that could be a little bit interesting because if I'm not mistaken, the M2 processor has like a has some things there. But as far as just running Jupyter Notebook itself, no, there shouldn't. I agree, there shouldn't be an issue.
Yeah,
Yeah.
and even if there was, you could use like a cloud kernel as well.
Yeah, I keep getting an error anytime I try it, but I can get Jupyter Lab to work, and I can also get Jupyter Notebook to work on on VS Code. But once I try to do it, using the local host to get to my browser, it doesn't work. Internal error, 500 internal error all the time. So
Mm,
yeah, but
yeah,
it has
I'm
bigger
sure.
fonts than the Jupyter Lab. That's why I would have preferred it. But I guess I'll make do with VS Code. That's fine. Thank you.
Yeah,
You might try running it in a Docker container. That sometimes would
yeah.
help.
Right.
And if Anaconda, I found is pretty good. So maybe if you can get an Anaconda installed, you can run Jupyter through that way. But I
Right.
don't know.
Yeah. So that's what I did, and it didn't work.
Yeah,
Yeah.
yeah, it's definitely not my wheelhouse. I'm sorry.
All right. It's okay. Thank you.
All right, we good to roll on to pandas, or we got anything more? All right, I will roll on to pandas, please.
Yeah. Bruce is asking real quick, what does it really mean to instantiate?
Oh, okay. Well, I will answer that confidently from a .NET perspective because I'm much stronger in .NET than I am in Python. But if I was answering one of my .NET students, I would say that when we instantiate something, we are creating an instance of it. So I have defined the point class. I've said the point class has some attributes. It's got an X and a Y property here. And this is just sort of a template that we use to create other things. And when we actually instantiate it with saying, hey, I have an instance of a point that lives somewhere in my computer's memory, and I'm going to store that location in the variable p, and I can refer to it later on. But I can have all sorts of two-dimensional points in my application as much as I need to draw, let's say, a stick figure or whatever. And they're all following that same template, that same class. So that's what we say when we say instantiate, because we're programmers and we like to try to sound smart. Okay, so pandas. Pandas is a lovely library for working with tabular data. It's a great way of working with things in what we call a data frame. You can load up a data source, and from there you can kind of visualize that data and you can manipulate it over time. I happen to have a number of data sources here in our data folder. We're really only going to be looking at one of them today because I'm very much a nerd. But I have a data source of Doctor Who episodes. So this is a comma separated value file, and we see it's got a lot of stuff. There's some JSON in there. We're going to kind of ignore the JSON, but it's a list of all these episodes of the TV show Doctor Who. And what we're going to do is we're going to load that into a data frame using the pandas library. And that's going to let us interpret that data and analyze it and understand it and refine it. And that's really important for when we start doing things like visualizing it with Plotly, like we'll do on our next notebook here. So the code that we use for this is we are going to say import pandas as PD. Almost everybody calls it PD when they're importing pandas, so that's what I'm going to do here. And this is a library that I've had to install. Actually, because I'm using Anaconda, it already comes pre-installed in the Anaconda environment. It's one of the nice things about Anaconda is it has all these other data science libraries already built into it. There's another one we often will import. It's called NumPy, numerical Python. And we call this one NP typically. Pandas is working with two-dimensional data, and NumPy is really good for representing things in terms of like high-performing arrays. So think about pandas as being composed of all these little NumPy arrays, one for each column and maybe one for each row. I'm not sure about the internals of how pandas works, but pandas is very reliant on the NumPy library. The next thing I'm going to do is I'm going to call pandas. I'm going to say read CSV. I'm going to tell it what file I want, what data file I want. So I'm going to say inside of my data folder, I've got a file named Doctor Who episodes.csv. I'm going to store that into a new data frame. I'm just going to call DF because I'm a lazy man. And so that's going to read my CSV file into a data frame. And now I can get a call df.head. And what this does is it says, hey, show me the first 5 rows by default. I can customize it to be something other than 5, but show me the first 5 rows of my data. And when I run this, I go out, it's going to load that into that data frame. And now I see I've got my first 5 rows. I see I've got an episode ID, an episode number, a title, a weekday that it aired, a broadcast hour, a duration, viewership in millions, it looks like, a share with a percent sign here, AI, which we're going to talk about what that means in a little bit, and a number of other things. And in fact, we can scroll right and see just a whole lot of other columns. So this is a data source I got from Kaggle.com some time ago, and I've refined it a little bit to clean up some things. But we're going to just play around with pandas to see what we can do to understand this data source and the nature of it. And there's some things we can do just really easy. So we notice how it chopped off some of the columns with this dot, dot, dot. If we really want to see all the columns, I could say dataframe.columns. And just says, hey, here are the columns I have. And so that gives me a nice list of all the columns that are present. If I wanted to look at, let's say, the last episode, I could say dataframe.tail and say, give me only the last 1 row. And that's very similar to doing dataframe.head, for example. There's another one that's kind of neat. It's dataframe.sample. Say, just give me 2 random episodes of Doctor Who. Let's see, Death in Heaven and Vincent and the Doctor. And if I rerun this, let's kill Hitler and the end of the world. So yeah, that's Doctor Who naming conventions right there. And so we can rerun that as many times as we want. We get a random sampling of rows. So that's kind of nice. As somebody with a kind of a statistical leaning nowadays, we have the ability to do descriptive statistics. If that makes you nauseated, just plug your ears for a minute or two and we'll be okay. But descriptive statistics are talking about how our values distributed numerically, like what are the lowest we see for rating and the highest, and things like that. And we can do this really easily by saying dataframe.describe, and just call that function, and get back a new data frame, really, that's all of these columns. These are the numerical columns, and it talks about, hey, here are the unique values we had. So there's 146 values of each one of those. We've got the average of each of these things. So if we're looking at, let's say, the average rating, we see the average rating is 7.9. We get the standard deviation. Then we get the min and max and all these little quartile values. So you can kind of see just numerically how these values are distributed. We're going to talk on our next notebook about maybe some less numerical and more visual ways of looking at this data. But we could just call describe and get some really helpful descriptive statistics. If you were caring about, like, hey, what's the value at the 42nd percentile? It'd be df.quantile. I can see a 0.42, and 42% of the way through the data, this is what these values would be. And I can customize that as I need to. This is not what I look at a whole lot, but if you had a very specific question of like, what's the 35th percentile of this look like? Well, you have a method built right into the pandas to let you do that. You can also do some interesting things, like let's say I wanted to look at the ID of the Doctor. By the way, for those who are completely unfamiliar with Doctor Who, it's a British science fiction show where you have the main character is the Doctor, and periodically they will regenerate this or recast that character as another actor. And so the ID of the Doctor is basically which actor it is or actress. And so if I'm just looking at this thing, it's showing me, hey, here are all the values that I have. And that's not super helpful. But let's say I want to see the unique doctors that I have. In this data set, we have Doctor 9, 10, 11, 12, and 13. So this helps me get my unique values that are present there, and it can help me find bad data as well. In this case, these look like reasonable values, but I might have found like a not a number or something uh, just random that I might need to clean up just by looking at that unique value there. So that's neat. One of the things Pandas lets you do is it lets you clean up the data. So it's not just a static view of your data, but you can actually manipulate it as well. So I could say dataframe.rename. I've got a column right now that doesn't make a whole lot of sense. And that column is AI. And you might think, well, that's artificial intelligence, right? Let's talk about ChatGPT. Well, no, not so much. That's an appreciation index is what what that actually means. And so I might say, all right, I want to rename that, and I want to just show me my columns afterwards. And this isn't going to work, but it's going to be really close. So we see here, we still see it's AI. We don't see appreciation anywhere. This is because data frames in Python are immutable. They don't change. When you do something like rename, you are actually creating a new data frame. So if I really wanted to actually rename that data frame, that column, I could say data frame is equal to the result of renaming this column. And then once I do that, now I should see AI is now appreciation. Okay? So every operation on a data frame, probably every operation, most operations are immutable. So they are creating a new data frame. And so you'll see a lot of this data frame is equal to itself dot something. That's a pattern that we go through a lot. There's also the option of saying comma in place equals true. That's an alternative, and that says, hey, don't be immutable, just change yourself. So that's kind of cool. So that helps people understand, hey, this is what this column actually means, because AI, I couldn't remember from my data source a year ago what that column actually meant. Let's say we wanted to drop a column or two. So right now, I'm looking at my columns. I've got some stuff that I don't think I'm going to use very much. I can go in here and I can say, hey, I really don't think I want some columns. I'm going to drop some columns. And the columns I don't want anymore, let's say I don't care about the cast because that's a JSON column and I don't have time to parse that on this on this talk. I've done it before and it sucks. But let's say I don't care about that column. I can also drop the crew. I could drop the air date, drop the episode number, and let's say I want to drop the duration as well. And scrolling over my cheat sheet here, I also want to drop my broadcast hour. And doing all of that is going to give me back my results in my data frame. And let's say I just want to take a look at the first row. When I run this, I'm going to get rid of all those columns I didn't care about. And now I just have the things I do care about. And so you see, actually, it's no longer giving me this dot, dot, dot. It's now showing me all of the columns, which is really nice. It also shows me I have maybe a couple issues here because I see summary is not a number. That doesn't, I agree that a summary shouldn't be a number, but, NaN is probably not a good value to have displayed to a user later on. So now we're going to go in and we're going to do some cleaning. And we're going to take care of some of the quirks we see in this data source. So it's going to be very hard to get a good read on the viewership with an M at the end of every view. It's going to be very hard to get a good read of the shares with a % at the end there. So let's clean those two things up. So we're going to remove % from share. I'm going to say the share column is equal to itself. Treat the value as a string and replace % with an empty string. By the way, this is not code that I'd be able to write on my own without referring to my cheat sheets. I'd have to do some light Googling. That's very normal for me with Plotly and Pandas. But I'm sparing us that today. Now I want to remove M from the viewership. I'm going to drop the millions. I can treat it as a numerical column. Treat it as a string and replace M with an empty string. Two very, very similar things. And I'll just say data frame head 1. I'm able to kind of play with my data, and now I see I've dropped the percent sign, I've dropped the millions indicator here. My data is now looking a little cleaner. It's a little nicer. So this is part of how Pandas and Jupyter Notebooks kind of go together to help you iteratively clean up your data and experiment with things and just get a good pipeline. And I can give this to my coworker and she can just rerun the whole notebook and say, "Ooh, you made a mistake here, Matt. This is not, maybe not billions, but millions." And she can correct my code or say, "Well, what if we didn't do this? What if we did something else other than this?" So it sort of documents all your decisions that you're making too when you're cleaning up your data and just interpreting your data. So that's some really good benefits here. Uh, I don't like the nan summary there. So let's say I want to change my summary. I'm going to say summary is equal to itself. I'm going to replace in A. So I'm going to replace any not a number values with, let's say, no summary available. If I do df head, this means my top 5 rows. I can see these all now have no summary available. And this data is starting to look cleaner and cleaner and cleaner, which is great. If I wanted to make sure that I didn't just replace all of those, I can say, okay, well, let's just take a look at the summary again and give me my unique values, please. We can see, okay, looks like we have some values here. Yeah, we got some weird encoding stuff going on. Probably ought to clean that up, but I don't have time for that today. But I can see that not only do we not have any not number values anymore, I do see this, that we do have other data as well. So this is showing us how Python and Pandas can help us clean up the data that we have. But you can also do feature engineering where you're adding in new columns. So in our data set, we have 5 doctors. We have 9, 10, 11, 12, and 13. And if you're not a Whovian, yes, we do refer to them by their numbers or by their indexes, which is kind of funny. If I wanted to add a new column to saying, hey, does it have the 9th doctor? I could do one here like this. I can say is equal to doctor ID is equal to 9. And that's going to actually add in a new column for every row in my data frame with a value of either true or false. So if it was the 9th doctor, that's Christopher Eccleston, it's going to have a true in this new has 9. Otherwise, it will be a false. So this is kind of this, they call it a vectorized operation that's run in parallel over your entire data frame, real nice and quick, super easy. And through the magic of code duplication, one too many, I can actually go in and I can rewrite this and I can have this, one per other doctor. And there are better ways of doing this. And I'll show you one of them in a second. But this is a real quick way of adding together data to give me 5 new columns. Now I'm looking at this. And if I scroll right over here, I've got has 9, has 10, has 11, has 12, has 13. And we can see this is kind of sequential data. So most of them start with the 9th doctor. So that makes sense that all these would be true and all these would be false. But just like that, I can add in new columns. And that's, really not a whole lot of code for me to do that. Now, there are some things that are a lot of code. Python, it turns out, Pandas has a way of doing that automatically. And so let's say if I'm looking at my weekdays column. So let's say I'm looking at weekday, and I want to say my unique values for the weekday column. Now I've got episodes aired on Saturday, Sunday, Monday, Tuesday, and Friday. Well, I can do the same thing that I just did, copying 5 lines of code, or I can call the magic Python function I had to Google, and I can have Pandas do it for me automatically. So let's take a look at that code. So it's something called get dummies. And dummies is just sort of this term we use for whatever reason to refer to adding in these dummy columns per unique value that we see. So one for Saturday, one for Sunday, one day for Monday, that kind of thing. And I have to tell it what columns I care about. I care about the weekday column. I'm going to say I want it to drop the first result, let's say true. and I want to give it a prefix. And the prefix here I'm going to say is just going to be day. And this should actually go in and modify my data frame. If I look at this, I see I now have, come on now, day Monday, day Saturday, day Sunday, day Tuesday. And so I don't have to do this manually like I did before with these 5 rows. It now works for every distinct value. It's added a new column for me, which is really neat. So that's something we'll do a lot in machine learning, for adding in together different columns to say, hey, do you have this attribute? Do you have this attribute? Do you have this attribute? It makes it easier to A, visualize, and B, it makes it easier for a machine learning model to kind of seize on that. And we're often doing things around that nature. Now, one thing about visualizing these data sets, it can be kind of hard to visualize true and false. So sometimes you'll want to actually replace values. So let's say for the entire data frame, I want you to replace any false value with a 0 and any true value with a 1. So that will help my data aggregation work a little bit better, because trues are now 1 and falses are now 0s. I could say df equals df dot replace, or I could say in place equals true, just to show you the other way of doing that. And that's going to actually replace all my data without me having to say df equals whatever. And just to show you that this worked, I'm going to show you the unique values for has 11, and they should be 0 and 1, not false and true. There we go. There are the unique values we have for 0 and 1 in that particular column. There's a lot of really cool stuff you can do with pandas. I always feel like I'm just scratching the surface. You can actually take together 2 different data frames and merge them together like a SQL join. You can apply functions to every row or every column to calculate values. I've had to do that before to parse out those JSON columns and stuff like that. There's all sorts of really crazy cool stuff you can do with grouping and aggregation and pivoting. Stuff that I don't necessarily have good excuses for with this data set. But if you're interested, there's a lot of good resources out there on how you might do that. If you are still allergic to statistics, you might want to plug your ears again. I think this is really cool. You might not agree, but we can actually do a really quick correlation analysis. And that's saying, essentially, how closely related is this column with this column? What's the relationship between the viewership column and the rating column, for example? Code for that is really, really, really simple. Dataframe.core for getting correlations. And it outputs something kind of scary looking, but it's just it's just a readout of how tightly correlated each column is with each other. So let's say I wanted to see the effect on the rating column of if it had the 11th doctor. That's my favorite. And we could see, excuse me, sorry, there's a 0.1 correlation. So it's close to 0. So it's saying, it's a slightly positive correlation. The rating might be a little higher, but it might also just be random noise. Versus if you're looking at the 10th doctor, it's a little higher. And if you're looking at the 13th doctor, well, this is actually a pretty strong negative correlation. So we see that if it has the most recent doctor in Doctor Who, she was not very well received, or at least her episodes weren't. And so it's saying there's a very strong correlation with lower ratings for this particular doctor. Again, looking over a table of numbers is maybe not the funnest thing to do. I'm going to show you a better way of doing this when we get into Plotly in a minute here. I'm going to take a drink here for my voice as I'm recovering from a cold. So as we stare at this wall of numbers, what questions do we have about the things that I've thrown at you so far?
Matt?
Yeah.
Does Pandas have some functions that you know of that will process these so they can be broken down into ordinal or ranking data or Boolean or whatever, because sometimes the things look like they're a certain type and then it doesn't work out that way.
There are ways of treating certain columns as certain data types. So I'm not so great at that, but I know, let's say, for example, type. I can take a look at the type of this column, and I know that there is a way of saying, hey, this column really is not a float. This is really, ordinal. This is a string. And so you can actually recast these things that way. I know particularly when you're loading up your data, you can say, hey, this is a date column. It's important for you to treat this as a date column, for example. It has some ways of handling things like that. That's something I always have to Google whenever I'm dealing with it. I don't feel like I have full mastery over the type system for the columns yet. It's one of the things I'm hoping to gain over my class this summer. Did that address your question, or were you asking something else?
Oh, that's fine. Thank you.
Mm-hmm. And you can also do stuff like sorting the values as well, which is really cool. But ooh, sorry again. But generally, when you're going through all this processing and cleanup work and the like, generally I will like to save this when I'm done. So I have a notebook here just for exploring my data and cleaning it up and saving it into a different file. So I treat it almost like a processing pipeline in my experiments in case I want to repeat my experiments later on. And what you can do is you can say, hey, I've got my data frame. I want to export it to, and we see got a whole lot of options here. Some of these I don't even understand, but to CSV is great. I want to save this thing inside of data as processed.csv. And this already exists because I've already done this experiment. But if it didn't, it'd create it. And that actually just goes out and it saves the results of my current data frame to a CSV file called process.csv. We can see here we've got all of that data. There's some oddities here with empty rows, so that might be something with the description column. Perhaps has some blank spaces there. That looks like that might be it. But this seems to handle just fine. So it actually persisted it for me to disk, which is really nice. So usually what I'll do is at the end of a processing thing, I'm going to output the results to another file, and I don't save it back to the original file just so I can repeat the analysis as many times as I want. So I treat it almost like a link in a chain for my experimentation. What else do we have for pandas? Oh, I see Bruce's question in chat. Is there an easy way to merge 3 or more data frames together, similar to a left join? So there is a merge. The merge lets you join one at a time. So you do.
Yeah, I'm wondering if there's a way you could do it like in SQL, where you're actually joining them at the same time. Yeah, I know you could merge. You could do a merge of 2 tables, and then merge it again. But I'm wondering if you know of a way you could do it a little bit more elegantly.
Nah, no, I tried to solve the same problem in January, and what I had to do was I had to merge A and B, and then B and C, and then D and D.
Okay.
It kind of sucked, but it worked.
Yeah, it kind of sucks.
Yep.
All right, thanks.
Yeah, no worries. But yeah, Pandas is really powerful, and if you get stuck on something, usually you get some pretty good results just from a quick Google search. Once you learn, like, here's the terminology I use when I'm searching. So that's really nice. But I always feel like I'm just scratching the surface on this stuff. So, but it's super powerful, and it actually performs pretty well. But of course, there's always improvements to be made. And if you're dealing with data at scale, you're probably dealing with more something like PySpark or something else that's inspired by pandas, but built for larger data. But let's move on to Plotly, because I like pretty diagrams and pictures. So Plotly is one of many, many, many different ways of doing data visualization with Python. It is my personal favorite way of doing data visualization with Python. Doesn't mean it's the best. It just means that it clicks very well with my brain. We're going to see why I like it in a minute here. But first, I'm going to go in and I'm going to just load our sample data. So I'm going to go in here and I'm going to go import pandas again. I'm going to say df equals pd dot read CSV. And now I'm going to load up my processed CSV. This is the one that we just saved to disk. Okay? And one of the interesting things about this that surprised me the first time around of it is I actually magically gain a column here called unnamed 0. And this I gain every time I do this, because there's something about the writing it to CSV and then loading it up again. I always get this unnamed 0 column that's basically just the row number that got persisted. So I'm going to get rid of that. I'm going to say df.drop columns equals unnamed 0. I'm going to say in place equals true. And that's going to modify my data frame without me having to set it equal to itself. I can run this as many times as I want, and every time it's going to load up that file and then drop that column. But otherwise, this is the exact same thing that we saw a little bit ago in our data file. So we see our data there. So now that we have our sample data, we can start to visualize it. Plotly Express is the library I like. Plotly is a very full, capable data visualization library, very similar to Seaborn or maybe Matplotlib or something else like that. Plotly Express is, I guess, a subsequent update that says, hey, what if you didn't have to write all this stuff and deal manually with all its objects? What if you had like a really fancy helper method that would let you make these types of charts that you want to make? And so everything I'm showing you today, or almost everything I'm showing you today, uses Plotly Express, which we typically call PX. Now, I now have these 3 things here. All of these things I don't have to do. I just personally find I like the look of my charts when they use these particular color schemes and the dark theme and these kinds of things. So I'm just kind of globally customizing the charts that Plotly Express is going to generate to fit in with my IDE's theme as well. So I'll run that. It's going to load the Plotly Express library, and it's going to configure the global defaults for things, so I don't have to customize it for every chart. And here's where the really cool, fun stuff comes in. We get to start working with charts. So when I say px dot, I get all of these charts that we could do for Plotly. And I'm going to say I want to do a scatter chart, right? And the first parameter is always going to be the data frame. So I'm going to give it my data, and I'm going to tell it the things I care about. Let's say on the x-axis, I want you to go with the season of Doctor Who that it is. And for the y-axis, I want you to go with, let's say, the rating. I'm going to give it a title here of episode ratings by season. Why not? I give this a run, and I get a nice little scatter plot with some purple colors here. And if I hover over something, I see I've got, season 3 rating of 9.8, season 9 rating of 9.6. Oh, okay, that's good functionality that I didn't really have to do a whole lot to get. I can even zoom in on a particular region of interest to me. And I think that's pretty neat. I can zoom back out, go back home. It's got a lot of cool stuff just sort of built in out of the box. But then I can start customizing it a little bit more. I can start saying, hey, I want to, let's say, color it by the appreciation index. And now I see I've got this nice little kind of a heat map that shows, hey, episodes that have a high appreciation are going to be my yellows, and the lower ones are going to be the purples. And so now I see that extra data point that's present here. I can see a little bit more information. But if I wanted to customize the information even more, I can say, hey, give me some more hover data. When you hover over anything, I want to see the title of the episode. I want to see the doctor ID. And now that same chart now tells me a whole lot more. It's like, oh, this is Blink, starring David Tennant. Okay, what's this one? Heaven Sent. Oh yeah, that's a very popular episode. And you start looking at all these little things and saying, all right, well, what was this one? Oh, okay, yeah. Yeah, okay, yeah, that explains that. So you're able to kind of customize these values, right? So it's really cool. The thing I really like about Plotly Express is I don't have to write a lot of code to get a lot of value and a lot of interactive value. That's why I really like this particular library. It gives me some very good visualizations just sort of out of the box. And let's say that I really want to push the envelope. I can take that exact same thing. And I want to do a 3D scatter plot. And for Z, I want to see the votes, the number of fan votes for this thing. I'll run the same thing. I now get a nice 3D thing that makes me want to throw up sometimes. But I can see, on my Z-axis here, I've got the votes. On my X-axis here, I guess I got the rating. And on the Y-axis, I've got the season. And here I see that's kind of flipped, so that's like the later season than the earlier seasons. But this already helps me understand the sort of the shape of my data a little bit more. I don't like this as much for sharing it, but it's kind of cool for exploring your data, and you can see, hey, fans really, really, really like Blink, and I like that episode as well. So I don't blame the fans. So this is part of why I like this stuff so very much. Scatter plots are one of my favorites, by the way. Often we'll like to see distributions of things. So let's say that we wanted to take do a histogram, and I wanted to work with that same data frame. I want to see just what's the distribution of ratings. And just like that, I say, hey, we have some episodes that have a rating of 5 to 5.4. Some episodes get a rating of 9.5 to 9.9. Yeah, but most of them are over here. And if I didn't think that adequately fit my data, I can actually tweak with the number of bins that it generates. I can say, hey, instead of the default value you're doing here, just have 50 of these columns. And now I get a lot more detail and nuance to it. So I can tweak with this as much as I want. I can still color it if I want to. So let's say I want to colorize this by whether or not it has the 13th Doctor. Now I can see, okay, so, there's definitely some trends we're seeing here with the 13th Doctor, maybe having the lower rating episodes. If you really want to make a noisy chart, you can. They give you the ability to do marginal values. So we can say marginal is equal to rug, and that gives you like this little strip here that shows you like the frequencies. For this one, it's not that helpful, but there's one that's maybe a little bit better. A little violin plot up here that shows me kind of the distribution. We can see, hey, the 13th Doctor, yeah, her episodes they weren't rated very well, and some of that is just it's a later in the series, so the quality's declined, and others might be just creative direction and other things like that. I believe there's also the box plot as well, so you can do a box plot. There's a lot of things you can do with this. Whether or not you should do them, it's sort of up to you. But these tools are available to you to just tack onto your visualizations and expand them and see what else we can do to understand it. Now, the cool thing about this is that any histogram you can also represent as a box plot to get more of a statistical distribution look. So I can do a box plot at data frame. You say I want to take a look at the ratings and how those are distributed. I can say, hey, ratings are distributed between this and this. Here's our median value here of 7.9. And if I wanted to maybe see more of the data on the points, I can say points is equal to outliers. In this case, it doesn't think it has any outliers. Expected outliers. It doesn't think it has any. So that's not a terribly good demo there. But I can also show you just all of the points as well. And that shows us just the full distribution. That's not super impressive, but I could colorize it by, let's say, the Doctor ID. And now I start to see a little bit more of this distribution by the Doctor, or maybe the distribution by the season. You can see more of how that sort of scatters out over time, which is really cool. And anything you can do a box plot for, you can also do a violin plot for. Oh, that's a lot. Let's go simpler with the Doctor ID. And now we get more of this kind of a box plot type of thing, but we have more of a violin shape to it to see more of the density to where the data is distributed. So a lot of really cool stuff you can do. And if you really can't decide between a box plot and a violin plot, I think you can actually do a box inside of a violin if you are so inclined. And please don't. But the library supports it. just out of the box without a whole lot of extra customization. So this is stuff that I nerd out about. This helps me understand data quite a bit. You might not be using box plots, histograms, or violin plots that much, but if you need to understand the distribution, it's really helpful.
Matt,
Yes, sir.
it looks like it's rounding the data to the nearest 10th. Is that something that it does on its own based on the data range, or is it parameterized to have to the nearest 10th?
Well, it may actually be the data as well. I'm not sure. Like if we're looking at the rating column here,
Yeah.
I think that it might actually have values that are quite like that. I think it's probably really the source data that we're looking at, as I don't think it does a whole lot of rounding on its
Oh,
own.
okay. Okay. Okay.
Yep. Yeah, no worries. It's been, I think, a year since I pulled this data set, and I think I expanded it a little bit to cover some of the seasons that it didn't have inside of itself. So I can't remember the particulars about this data set. But generally, it doesn't do a whole lot for you automatically, which is nice. Everybody loves bar charts. This is data I'd probably want to aggregate before I did bar charts on, but we're going to do a bar chart for it anyway, just for science. So I'm going to do a bar chart with my data. The Y column I care about is my share. This is the viewership share in percentage. I'm going to colorize it by the season, and I'm going to give it a hover data of the episode title. And this is going to look interesting, kind of pretty, but maybe a little busy. So we can see as the seasons go on how the viewership share increases and decreases over time. We can see here we have this spike right here with the first episode of season 4, and then a spike at the end of season 4. And you can see we have some similar spikes in viewership around the first or last episodes of a particular season. So this colorizing by season actually helps us spot some of these trends with a little bit more, which is interesting. If we wanted to colorize it instead of by season, maybe by rating, we can start to see the association between rating and viewership. And we have some episodes that are not that well regarded, but still had a pretty high degree of viewership. And some episodes that had some extremely good viewership or good ratings have relatively poor viewership. So maybe not that strong of a correlation there. But I really like to look at things on the color dimension and several other dimensions because you really help you find different associations. Line and area charts. I do apologize for these in advance. So before I show you those, I'm going to show you a polar chart because these are awesome. Polar charts are basically like, hey, we're looking at a map from the North Pole. So it's more of a circular bar chart in this case. So we're going to say bar underscore polar. We're going to look at our data. We're going to look at the value we want to look at is the rating. The color we want to look at is the season. And go. It shows us, as the seasons go on, how the ratings change. It really is the same data, but it's kind of wound around this circle. So there may be value in this in some data sets. There may not be. It is at least interesting, and it's fun to show you that because we can drop the word bar and change this R to a Y, and it's just a bar chart. Line charts. This data is maybe not the best for line charts, but we'll take a look. We're going to say line chart, my data. We're going to look at the date of the episode. We're going to look at the Y value is going to be the rating of that episode, so we can see ratings over time. And if we just run this, it looks like some weird sewing pattern. We do see some interesting jumps or diagonal slants. This sort of accentuates the gaps between seasons. Sometimes with Doctor Who, there's a long time gap between different seasons. We can colorize it maybe by season. And that makes it a little clearer. Also colorize it, of course, by the Doctor ID as well. By the way, one thing I want to show you with this stuff is if you don't like the value that shows up in a margin, let's say we don't like the legend showing us doctor ID, I can say labels equals, and I can give it a dictionary. I'm going to say when you see doctor ID, go instead with doctor. Just with that change, I'm able to customize just that axis, which is really handy. One of the things I'll often do is I'll have a separate object just for labels and hover data, and I'll give all my charts that same object for labels and hover data. And it just sort of keeps my settings for these axes together over time, which is cool. Anything I can do as a line chart, I can also do as an area chart. And it's going to look great, but I can do it. This one in particular, I don't particularly like that little slant between seasons. I don't do enough with line charts to maybe know how to deal with this. I suspect that we really just would want to give it a differently structured data source that has more natural series built into it. So that's be one that I would need to maybe dig into a little bit more. And then, of course, because why not? You can represent things not just as a line chart, but as a 3D line chart. And say we wanted to look at the Z value of the appreciation index. See kind of a 3D pattern. Maybe not that helpful for all your data sets, but you can see it's not a whole lot of code to get that effect. So with the right data set, that's cool. Pie charts as a data visualization guy, I sort of hate to advocate for pie charts because pie charts are boring, but business users love them. They're pretty easy. You say, hey, here's my data. I want the values that we're going to take a look at to be the viewership. I want the names to show to be the doctor ID. It's like that. Oh, no. There we go. Just like that. We get the doctors over here and the percentage of viewership that each doctor is responsible for with each major bucket. So we can see that the majority of viewership of Doctor Who came from David Tennant, but Matt Smith was pretty closely behind there. If this wasn't clear, we can always just say title is equal to viewership by doctor, and that helps people understand your graph a little bit more. There's always ways of customizing these things in a much deeper level. At the end here, I'm going to show you the documentation for Plotly Express and how much you can customize with this stuff. But my point here is really how much we get out of the box. That's why I like this library so much, as we can go just do a little bit of code and get a little bit of value right out of the box. Okay, so we're getting back to the point where I have to apologize to you all for the visuals I'm about to inflict on you. That's life as we know it, but that's okay. So tree map. Tree maps are really good for hierarchical data or taking a look at multiple factors that might contribute to something. So let's say we wanted to take a look at the ratings of all doctors by their seasons, for example. So I could say express a tree map. I want to take a look at my data, because of course I do. The values, I want to take a look at rating. And I also want to color by rating. So far, that's nothing that unusual. Now I need to give it a path. The path is going to basically say, hey, here are the things I want you to drill into for this particular data source. The first one you want to do is it should always be a constant value. It looks really wrong if you don't do this. So I'm just going to say all doctors is our root level. Constant doesn't change. This is just like everybody has this. After that, we're going to look at the doctor. I'm going to give it another constant. To say all seasons. And then after that, I'm going to take a look at the season. And after that, we'll take a look at the episode title. See what happens if I don't do some of these things in a second. But this should give us, if I've formatted my code right, it gives us a bunch of warnings. This is as far as I can determine due to the internal implementation of Plotly Express's tree map. So I'm not sure what I can do to suppress these. Hopefully a future update resolves these. But I'm going to scroll over these like I don't see them. we'll take a look at the result. And here we see all of our doctors. We're colorizing again by rating, so bright is good, dark is bad. I can see, all doctors. I can see the 10th doctor, the 11th doctor, the 12th, the 9th, the 13th. And I can already see, well, the 13th doctor, yeah, that's much darker. And if I want to, I can click in and I can kind of zoom in on that particular region and say, okay, well, show me all the seasons that she's been involved in. She's only had one, and we can see now all the episodes that she's been involved in. And this is the best one, was about Rosa Parks, and it's a time travel episode because Doctor Who. But now we can now go back. I can say, hey, show me things around Matt Smith, 11th Doctor, all the seasons Matt's involved in. Now I've got season 7, 6, and 5. We can see, hey, here are the ratings and how they changed over time. This is sort of ordered like sequentially reversed. We might have wanted to sort our data first before we showed this, but that's okay. We can see, hey, here's what's going on with season 5. Here's what's going on with all seasons and season 6. We get this nice interactive look to things. Normally, I don't use a tree map with data like this. Normally, when I'm using a tree map, I am looking at maybe more of hierarchical data. I use this a lot when I'm looking at code files, so I can see, hey, how frequently is the code file changed? How many lines of code is it? That kind of thing, and that can be really helpful. But you can see this can already help you identify a few outliers, like, ooh, this was a particularly bad episode for this doctor, and ooh, something's going wrong here, and that's sort of the value of this stuff. But wait, it gets weirder. Oh, I promised you I was going to show you what it looks like without some of these things. So here we go. Let's take a look at another one. Let's say we're going to drop the constants. Just drop the 2 constant values. Just have the doctor, the season, and the title. Still going to work. It looks a little weird. The root level now is gray, and the hovering values are just weird. So that's why I like to always start with a constant, because you get this weird gray thing at the roll-up level. So I always start with a constant. We don't see any other really negative side effects other than now we see 11 and 7 and 6, and we sort of lose the context of, oh, this is a season and this is a doctor, right? So those constants really do help us organize our code a little bit better. Sunbursts. I'm sorry for this. Sunbursts are weird. They're kind of cool, but they are weird. Any tree map I can represent instead as a sunburst. And it's just a different representation of that data. And we get the same warnings. But now I've got a wheel. This really does highlight that the 13th Doctor's episodes were not really well received. But I can go in here and I can say, hey, show me the 10th Doctor. And here I see all seasons. And let's take a look at season number 4. I can see, hey, here are the episodes from that. That's pretty cool. I can sort of jump back up to the root level as well. So it's a good way of looking at hierarchical data and shares. This data, I would probably maybe simplify it maybe a little bit more. Maybe we drop the whole idea of a season entirely, and we just look only at that particular doctor and the episodes they're in. That makes it maybe a little bit more manageable. Now we can say, hey, show me Matt Smith. All right, so his good episodes were pretty good. His bad episodes, they weren't terrible. All right, let's take a look at Eccleston. Sorry, this is Capaldi. We see his best episode was the best in the series, and then he had a couple of stinkers, but otherwise a pretty good doctor. So really good for helping you understand all of your data in a hierarchical manner, and you get all this cool stuff out of the box just with clicking and all that cool stuff. All right. Last bit I have for you is revisiting the correlation stuff we did earlier. So earlier we did this correlation is equal to dataframe.correlation, and that gave us correlation matrix, which is scary math and all that good stuff. Well, we can do some cool stuff with this. We can actually visualize this in a helpful manner. Below I have a prettier version of this, which I'll run after I inflict this one upon you. So there's this IM show, which I'm not even sure what that stands for. I'm going to give it my correlation data frame. I'm going to say, hey, show me this thing. It gives me a nice little thing like that. All right, that's kind of interesting. Let's maybe take a look at use some more of the width available to us. Okay. Well, what if I want to see text on here? I can say text auto equals true. And now, really hard to read this. I'm running it again. Sorry about that. Very small. But we can start to see the same correlation data that we had up here in a heat map where the high correlation values are bright white and the low correlation values are dark purple. Now, this is a little distracting because we have this strong diagonal here where everything is very strongly correlated with itself, because duh. And then we have the whole thing just sort of mirrored across this axis. So some smarter people than me on the internet have come up with the idea of using a mask to sort of remove half of your data frame and then do the same thing after you remove half your data frame. So I'm not going to focus on their code. Result is pretty cool. The result gives us the same thing without that strong diagonal. And now we can start to see, hey, we got some high correlations here. We can see the 13th Doctor, her episodes came out usually on a Sunday, for example. If the season has a high correlation to the number of the Doctor, that's kind of stupid. That's saying, hey, as the show went on, they had a higher and higher number of Doctor. Like, well, no duh. That tends to happen. We also see that a very strong negative correlation between the season and the viewership share. So people have stopped watching as the show has gone on. Maybe we care most about our ratings. So what impacts our ratings the most? Well, we can see here that episodes aired on Sunday tend to perform worse. Episodes aired on Saturdays tend to perform better. If it has the 13th Doctor, people don't like it. If it has the 10th Doctor, people tend to like it. And then, as the seasons go on, the ratings go down. And then the more people vote for an episode, the better its rating are, which makes sense to me. Whoops. So most of this is fairly common sense. But what they're actually planning to do to fix Doctor Who is they're getting rid of the 13th Doctor and they're actually bringing back the 10th Doctor. So it actually coincides pretty well with the correlation analysis we see here. So this is just some of the nerdy stuff I like to do with Plotly and Pandas and Jupyter Notebooks, and being able to take a look at data and sift through it iteratively and explore the data with either descriptive statistics or with scatter plots or all these other crazy looking charts. And there's some really cool stuff you can do with Plotly Express, and the documentation is actually really fantastic. There we go. So we've got, too much enhanced. So let's take a look at the various types of plots we can do. So we've got all sorts of information about scatter plots. We've got information about all these things to show you trend lines and the like. And these are actually interactive in your browser, which is super cool. If you wanted to find out how to do something, you just do a search for, let's say, tree map. And it's going to walk you through basically everything you have to do to make a basic tree map. And then how do I customize this? If I really wanted to customize this more, what can I do with it? And so it walks you through all this stuff for every type of chart. The documentation is really, really good. So Plotly Express gives me a lot of the basics I need to have a really rich experience without much customization, but it gives me a lot of good documentation and the full Plotly library if I need it to customize the visuals that get generated. But the more you customize this stuff, the uglier your code starts to be. But there's some really cool stuff you can do with it as well. So heat maps, annotated heat maps, map box density heat map. Let's take a look at that one. So here's a geographical map with densities. So if you're looking at maybe air travel or delays in shipping or something like that, that might be helpful. Really, really, really cool library. There's Plotly implementations in other languages as well. So it exists in R, it exists in JavaScript, maybe other languages as well. I am a very big fan of Plotly just in general, but I also know people are really in love with other libraries like Seaborn and even Matplotlib because it does a lot of cool stuff out of the box without you having to learn a whole lot of new stuff. So this is very much a what's your preference kind of a thing. For me, this is very much my preference because it helps me get good results out of the box. and I love it. And let's see, how are we on time? Okay, so I got one final thing I want to show you, completely unrelated to everything that I've shown you thus far, except that it's a data visualization thing. As I've been doing more and more with polyglot notebooks and .NET in notebooks, I've come across an extension from Microsoft Research called, let's see, Sandance. This is a extension you can install in VS Code for free from Microsoft Research. And once you do that, you can right click on any data set, and I can say, hey, my Titanic data set, I want to view this data set in Sandance. And it gives me this nice little look here. I can see, hey, here's the age of people who were on the Titanic. Let's say I want to see, color them by, did they survive? And I can start to see, their survivorship basis and the like. So this isn't usually the Titanic data set I look at that much, so I might be a little out of my element here on looking at this. But we can sort things based on their passenger class, or maybe even group things based on their gender, or where they embarked on the boat, or their passenger class, colorizing it by survived, sorting by the passenger count. Yeah, we get this nice iterative way of sort of just understanding our data in a very interactive tool. So if you don't want to have to write a lot of code and you just want to take a look at some CSV values, well, you have it right here in this free extension for VS Code, and it gives you some really cool things. I've not played around enough with Sandance, but I wanted to sort of give it to you as a little cherry on top for sticking with us at for the whole talk. That's all I got. Thanks for having me. I hope you enjoyed it. I hope this was helpful. I will be checking in the final version of the code after we wrap here, so you can get sort of the final code for reference and play around with it yourself. You should be able to just pull it down, run Anaconda, and then just experiment with the data to your heart's content.
All right, thank you very much, Matt. Anybody got any final questions here?
Are you going to post the link to the recording?
Yes, I will. The site that I'll put it in the chat again one more time here. It'll be posted on there. As you saw on the front page with little cards for different posts. There'll be one for this meeting, and I'll post it there. Hopefully I'll get it up there tonight.
Okay, great.
Well, thank you again for having me. If you think of something later on, you can get me in touch with me on LinkedIn or Twitter. MattEland.dev is a really great way of finding where I am on all the social platforms and getting contact information. But yeah, it was a lot of fun to come over here and share this stuff with you.
All right, thanks a lot, Matt,
Very
and thanks
cool.
everybody for coming out tonight. Really good turnout. Again, I do not have a speaker for next month yet. I think Elaine said something earlier about having interest in the Python databases. If in about a week I don't have anything, I will probably post something like that, because I like to get these up several weeks in advance. So if there are no more questions, then we will see everybody next month. What'll that be real quick? I believe that's going to be that will be June the 19th. So we have looks like 5 weeks this time in between meetings. So June the 19th is when we'll see everybody. All right, I'm going to stop the recording now.